Hi guys, welcome to Data and Statistics. This is our first lesson and we're going to be talking about bar graphs today. But before we begin talking about bar graphs, I do need to cover some vocabulary words for this unit. So we're going to talk about samples and populations. Up at the top here, if you will go ahead and grab your math journal and a pencil and write these definitions down in your math journal so that you can kind of keep them fresh for this unit. A sample, guys, is simply a subset of a larger population. So it usually refers to something that has special characteristics about that population. When we collect data from a sample, we call that a sample statistic. So that in comparison to a population refers to the whole big group. So I'm just going to give you a quick example. If our whole population is our junior high population at Glen Rose Junior High, a subset or a sample of that population would be our 7th grade class. So it's just a smaller group that we can reduce and study and make predictions about the rest of the school. Now, when we're talking about collecting data from an entire population of people, that is called a population statistic. Now, a recent population statistic just happened April 1st this year. I just put mine in the mailbox. The U.S. government sent out a survey called the U.S. Census. And so we all had to fill in some data about who lived in our homes and then send that back to the government, and they will in turn study it and make decisions about how to run our country based on what information we gave. So that was a real live population statistic that we're dealing with these days. Okay, my next vocabulary word that I want you to know as we start this unit is a random sample. Guys, random samples are very important when we're collecting data. It's very important for everyone in a population to have an equal chance to be a part of a random sample. That means that your sample, your data, is unbiased. Okay, so it's very important to have unbiased data. That's the most accurate data, and that's exactly what we need when we study a population. So being selected in order for a sample to be random. Here's an example. If we took a survey in our junior high about what is your favorite sport, but we only asked girls what their favorite sport was, well, that would not be a random sample. That's a pretty biased sample, so that's not good. That means that that's not going to be the opinion of the entire group. So we, again, have to just be very careful when we're collecting data to make sure that it's by unbiased information. Okay, so why do we need to study data and statistics anyway? What's the big deal about it? Well, I can personally attest that as a business owner, I use data quite regularly. I study what happened in the past, and I use that information to predict how I'm going to what patterns my customers are going to have in the future. And so then I can plan for staffing, for budget. I can make sure that I have plenty of supplies for my business in my busy times. And then maybe if I know January is my slowest month here on the ranch, I know that I don't need as many supplies or as much staff in January, so I can throttle back a little bit. Another place where we're hearing statistics daily is the news, especially now that the news is covering coronavirus. I want you to listen to our president and Governor Cuomo from New York when he talks about his statistics. They are studying data about this virus. They're studying how many beds they need in the hospital. They're studying how quickly this virus is spreading in their communities, and what the odds are that people are going to catch it. And also, they're thinking about supplies and what is the pattern that this is going to happen. So please listen, because data and statistics are critical during these times when we need to understand how to behave. All right, so now that we've covered that, let's go ahead and jump into bar graphs. A bar graph is an awesome way to compare categorical data. So that simply means if your data breaks up into different categories, a bar graph is for you. So it can be represented vertically. As you can see, I have an example over here on the left. It can also be displayed horizontally. So I have another example over here. The longer that the bar is, that means that the greater the value is going to be. So anytime you add all of the bars together, you're going to get the total number for those data pieces. And we're going to work an example like that next. Okay, so here's example number 1. We've got a brown paper sack, and it's filled with all different colors of tiles. And so there is a bar graph that represents the colors of tiles over here on up above me here. So you can see that we've got 20 reds, 8 blues, 12 greens, and 10 yellow tiles in this bag. But you can see the representation of it. And that's essentially what a bar graph is. It takes the data from a survey and it puts it into a display that you can easily understand, and it will help you make a decision. So the question A says, how many tiles are in the brown paper sack? So guys, all we would have to do is add 20 plus 8 plus 12 plus 10, and I do that, and it's 50. So we know that there's 50 data pieces in this set of data that we're studying here. The next question asks, what percent of the tiles are blue? And I'm going to have you look back here on this example right here. So if we're going to find the percent of blue tiles, we first need to know how many tiles altogether are in this set. We've already decided that there were 50 data pieces. And then when we look on the graph here, we can see that 8 of them out of the 50 are in fact blue. So if I want to know what percent that is, remember when we learned about percent proportions, we can say how many out of 100 are the blue tiles. Now that I have a proportion set up, I can simply solve that proportion. And I'm looking here, I see a relationship. If I multiply times 2 in the denominators, I can do the same thing up here in my numerators. And so 8 times 2 is 16, and that would be 16% of the tiles are in fact blue. All right, I'm moving on now to the next example about smoothies. It's a very warm day today. In fact, it's 95 here in Texas. And so I came up with an example about a smoothie. I hope you get one today. So we're looking at this data, and you'll notice that the highest amount of smoothies that Sarah's Smoothie sells is in August. So you're just going to look for the longest bar, and that's the greatest value. The question asks, let's see. Oh, it doesn't ask us a question. So I do want to make note that here in December, it's the smallest bar. So as a business owner, Sarah Smith can simply look at this and say, okay, I don't need a lot of staff in December. I don't need to buy a lot of supplies, cups, and ice and all of this. So it helps her make important decisions about her business. Okay, now that we've had a little practice interpreting bar graphs, it's your turn. Yep, that's right. Go ahead and do IXL BB8. And as always, let's do some math.